Hello, grade 9 learners. So our topic for this week is problem solving involving parallelograms, trapezoids, and kites. The learning competency for this week is that learners solve problems involving parallelograms, trapezoids, and kites. So there are several types of quadrilaterals. So we are going to discuss types of quadrilaterals that are parallelogram, trapezoid, and kite. These quadrilaterals have different properties. So these properties are useful in solving problems, so we need to recall. Okay, so let's have now the parallelogram. What is a parallelogram? A parallelogram is a quadrilateral in which both pairs of opposite sides are parallel. Okay, so we have two pairs of parallel side. Okay, this pair and another pair. What are the properties of a parallelogram? So we have the opposite sides are congruent. Okay, so these markings, okay, means that they are congruent. Opposite angles are congruent. Okay, so we discussed this already. Non-opposite angles are supplementary angles. Okay, so it means the consecutive angles are supplementary. The diagonals bisect each other. So if we draw two diagonals, okay, they will bisect each other. And each diagonal divides a parallelogram into two congruent triangles. So if we draw one diagonal, we will have two congruent triangles. Okay, so let's have problem solving involving parallelograms. So we have this problem. In a parallelogram ABCD, okay, so this is the figure. In a parallelogram ABCD, AB is equal to 3x minus 5 centimeter, and segment CD is x plus 9 centimeter, and segment BC is 2y minus 7 centimeter, and we have segment AD, which is y plus 3 centimeter. So we are going to find the following. What is the value of x? Okay. How long is side AB? What is the value of y? Okay. How long is side AD? And what is the perimeter of parallelogram ABCD? So when we say perimeter, okay, so the measurement of the sides, okay, how long is the measurement of all sides of this parallelogram? So we have this solution. So to find the value of x, okay, we will use the property which is opposite sides are congruent. Okay, so we have side AB and equal to side CD, or we say it segment AB is equal to segment CD. Okay, so we have this from opposite sides have equal length. Okay, because they are congruent. And then we are going to okay, from the given, we are going to put the value of AB. Okay, we have 3x minus 5. And the value of CD is x plus 9. Okay. Substitute the given. And then we are going to combine similar terms. Okay, what are the similar terms? So 3x and x. So we will get the additive inverse of x. So will become minus x. Okay, then we get the additive inverse of minus 5. It will be plus 5. Okay, so this will become 0, and okay, also x will become 0. So simplify. We have 3x minus x equals 2x, and then 9 plus 5 equals 14. Then after this, we are going to divide both sides by 2. So after we divide, 2 divided by 2 will be x. 14 divided by 2 is equals to 7. So we have the value of x is 7. Now, let's have how long is side AB. Okay, so we're going to find now the value of segment AB. Now, so since we know already the value of x, okay, which is x equals to 7, so we are going to substitute it to the given. So we have 3 times 7 minus 5. Simplify, we have 3 times 7 is 21 minus 5. So segment AB is equals to 16 centimeter. Okay, now how about the value of y? Okay, so remember that segment BC is congruent to segment AD. So it means they are equal. Okay, equal measures. So we have BC, segment BC is equals to segment AD. Then substitute the given. Okay, so segment BC is equals to 2y minus 7 equals segment AD, which is y plus 3. Then we are going to combine like terms. So we get the additive inverse of positive y will be minus y. Get the additive inverse of minus 7 will be plus 7. And then simplify. 2y minus y equals y. And then 3 plus 7 equals 10. So the value of y is 10. Okay, so now we can find now the measurement or how long is side AD. Okay, this one. So since we know the value already of y, which is 10, we are going to substitute it. So it will be segment AD is equals to 10 plus 3. And we have AD is equals to 13 centimeter. Okay, so this means this is 13 centimeter and the other side is also 13 centimeter. And this one is 16 centimeter, segment AB. So segment CD is also 16 centimeter. Now, let's find out what is the perimeter of parallelogram ABCD. Okay, so we have this formula. So the perimeter is equals to 2 times length plus 2 times width. Okay, meaning the 2 length and the 2 width. We are going to add all the sides. Now, so the value of the length, okay, which is segment AB is 16 centimeter times 2 because of the opposite sides. They are congruent. And then plus 2 times 13. Okay, this is the measurement of this is 13 centimeter. So likewise, segment BC. Now, so we are going to simplify. 2 times 16 is equals to 32 plus 2 times 13 is 26. Now we are going to add this to 32 plus 26, the answer is 58 centimeters. So the perimeter of this parallelogram is 58 centimeters. Okay, so let's have another problem in parallelogram. In a parallelogram ABCD, diagonals AC, okay, this one AC, and diagonal BD or segment BD meet at E. If segment DE is 8 cm and segment AC is 13 cm, okay, we are going to find the following. How long is diagonal BD? And how long is segment AE? Okay, so we have our solutions. Okay, so let's answer the first question. How long is diagonal BD? Now, so remember the property that diagonals of a parallelogram bisect each other. Okay, so it means the diagonal will be divided into two equal measures, okay, if they bisect. Now, so we have segment DE is equals to 1/2 of BD. Okay, so meaning this is 1/2. Now, so if segment DE is 8 centimeter, okay, so equals to 1/2 times BD. Okay, so we will use this formula. Now, so we will get the, okay, or we get the multiplicative inverse of 1/2. So it means it is 2. So we will multiply both sides of the equation by 2. So 1/2 times 2 is 1. And then 2 times 8 equals 16. So meaning the measurement of segment BD is equals to 16 centimeter. Okay, now let's have another, okay, segment to find. How long is segment AE? Okay, so this part, no? So we have this formula. Segment AE is 1/2 of segment AC. Okay, so if segment AC is 13 centimeter, so we have to get the 1/2 of it. So 13 divided by 2. So we have segment AE is 6.5 centimeters long. Okay, so this is our answers. Okay, so let's have trapezoid. Okay, what is a trapezoid? A trapezoid is a quadrilateral with exactly one pair of parallel sides. Okay, so we have only one pair, okay, of parallel sides. This one are not parallel because if we extend the line or the segment, it will meet at the end, no? So they are not parallel. Okay, then in a trapezoid, we have a kind of trapezoid which is isosceles trapezoid. Okay, so it is a trapezoid with congruent non-parallel side. Okay, so in a isosceles trapezoid, okay, the non-parallel sides are congruent, meaning they have equal measures. Okay, and then the median of a trapezoid is parallel to each base and each length is 1/2 the sum of the lengths of the two bases. Now, so if this trapezoid, we are going to draw a median. Okay, meaning we will divide the non-parallel side into 2, the measurement of the median is 1/2 of the sum of the bases. Okay, so this one is one base, and then this one is the second base. So we have two bases. So we will add these two bases, the measurement divided by 2, that is the measurement of the median of a trapezoid. Okay, what are the properties of an isosceles trapezoid? So the base angles are congruent. So in an isosceles trapezoid, okay, we have base angle. Okay, this one, no? The base angle are congruent. Then opposite angles are supplementary. Okay, so the measurement of this angle and the opposite of it is equals to 180 degrees. And the diagonals are congruent. Okay, so if we draw two diagonals in an isosceles trapezoid, they have equal measures. Okay, so let's have problems involving trapezoid. Okay, so we have this problem. In an isosceles trapezoid, ABCD, measure angle A is equals to 3x plus 40 degrees. And measure angle D is x plus 60. Now, so we are going to find the following. What is the value of x? Then, find the measure of angle A. And we are going to find the measure of angle B. Okay, so we have these solutions. So first, we are going to find the value of x. Now, so remember the properties of an isosceles trapezoid, that base angles are congruent. So meaning angle A is congruent to angle D. So if they are congruent, meaning the measurement of their angles are equal. So meaning measure angle A is equals to measure angle D. Now, so let's have now the given. Okay, so angle A is equals to 3x plus 40, and angle D, measure x plus 60. So we have to equate this, and then we are going to combine like terms. So what are the like terms? So we have 3x, and then get the additive inverse of positive x, it will be minus x. So 3x minus x. Now, we will get the additive inverse of positive 40, so it will be minus 40. So we have, okay, this will become 0. So 3x minus x is 2x equals to 60 minus 40 is 20. Now we are going to divide both sides of the equation by 2. So we have 2 divided by 2 is x, and then 20 divided by 2 is 10. So the value of x is 10. And then we are going now to find the measure of angle A. So since we know already the value of x, so we are going to substitute it to the given. Okay, so we have 3 times 10. Okay, 10 is the value of x, plus 40. Okay, next, simplify. 3 times 10 is equals to 30 plus 40. So we have measure angle A is equals to 70. So angle A is 70 degrees. Now, how about measure of angle B? So we have, okay, the property of an isosceles trapezoid, which is opposite angles are supplementary. Okay, meaning the measurement of the two angles is equal to 180 degrees. Now, so we have, okay, measure angle A and angle C are, okay, they are supplementary because they are opposite angles. Now, so we are going to have this measure angle A plus measure angle C is equals to 180. Now, since we know that measure angle A is equals to 70 degrees, so 70 plus measure angle C equals 180. Then we're going to get the additive inverse of positive 70. It will be minus 70. So measure angle C is equals to 180 minus 70 equals 110. Okay, so measure angle C is equals to 110. No? So this is 110 degrees. So we have this property which is base angles are congruent. So if angle B and angle C are base angles, so we have to say that they are congruent. So measure angle B is equals to measure angle C. So therefore, measure angle B is equals also to 110 degrees. So by the way, okay, angle A and angle D are base angles of this side. And then angle B and angle C are base angles of this side. So meaning in a trapezoids, we have two bases. Okay, so the segment AD is a base, segment BC is also a base. Okay, so that is the measurement of angle B, 110 degrees. So if this is 110 degrees, this is 70 degrees. Okay, they are supplementary. Okay, this is 70 degrees and this is also 70 degrees and this is 110 degrees. Okay, so let's have another problem involving trapezoid. Okay, so we have quadrilateral ABCD is a trapezoid with segment EF as median. Okay, so if segment AF is 3 units and segment AB is 4 units, find segment DC. Okay, so remember that in this trapezoid, segment AB and segment DC are the bases or the base of this trapezoid. Now, so we have this solution. So since the median of a trapezoid is parallel to each base and its length is 1/2 of the sum of the length of the two bases, then okay, we have this formula. So it will be 1/2 of AB plus DC is equals to segment EF. So we are going to add the measurement of the two bases and then divided by 2 or 1/2 of it. Okay, that will be the median of the trapezoid. Okay, so let's have now the given. So substitute it in the formula. 1/2, the measurement of AB is 4 units plus DC, okay, equals to 3. Okay, 3 is the measurement of segment EF. Okay, now, okay, we are going to get the multiplicative inverse of 1/2, that is 2. So multiply both sides of the equation by 2. So 2 times 1/2 is 1. No? 2 times 1 is 2, divided by 2 is 1. Now, and then we will multiply also 2 times 3. So it will be 4 plus DC. Okay, this becomes 6 because 2 times 3 is 6 now. And then simplify, get the additive inverse of positive 4. It will be minus 4. So segment DC is equals to 6 minus 4. So segment DC is equals to 2 units. Okay, so if we are going to check, okay, we will add, okay, the bases. 4 plus 2 equals to 6. 6 divided by 2 is 3. Okay, so that is the measurement of the median of the trapezoid. Okay, now let's have another type of quadrilateral, which is kite. What is a kite? Now, a kite is a quadrilateral with two distinct pairs of adjacent sides that are congruent. Okay, so this is our kite, kite MNOP. Now, what are the properties of a kite? In a kite, the perpendicular bisector of at least one diagonal is the other diagonal. Now, so if we notice, okay, we have diagonal segment MO and segment NP now, and then they form, okay, they have a perpendicular line, so meaning they meet at 90 degrees. Okay, these are perpendicular, and segment NP is, okay, divided into two equal measures, so meaning it is a perpendicular bisector. Okay, this one is the bisector of NP. Okay, so this diagonal NP have equal measurement. Okay, it is bisect, okay, into equal measures. But segment MO, okay, if you notice, okay, they are not, also it at least one, okay, only one diagonal bisect. Then the area of a kite is 1/2 the product of the length of each diagonals. Okay, so we can find the area of a kite by getting the 1/2 of the product of the length of each diagonal. Okay, so let's have problems involving kite. Okay, so we have this problem. Quadrilateral MNOP is a kite with diagonals NP and MO. Okay, so we have this given. Segment NP is equals to 3 centimeter. Okay, this is 3 centimeter. And segment MO is 6 centimeter. Find the area of kite MNOP. So we're going to find the area of this kite. And another one, the given is area of a kite MNOP is 14 centimeters square. And segment NP is 4 centimeter. How long is segment MO? Okay, so in the second given, the area is given and one segment and one diagonal, and we're going to find the measurement of another diagonal. Okay, so let's have the solutions. So we will use the property of the kite, which is its area is 1/2 the product of the length of its diagonal. So we have this formula. So area is equals to 1/2 of the two diagonals. So what are the two diagonals? Segment NP and segment MO. So we are going to solve first letter A. Now, so given here, we have segment NP is 3 centimeter and segment MO is 6 centimeter. So we will multiply these two diagonals. 3 times 6 is 18 centimeter. And then 18 centimeters squared, okay, 1/2 of this, so divided by 2. So the area of the kite is 9 centimeters squared. Okay, that is how we get the area of the kite. Now, so let's have now letter B. So given here is the area, which is 14 centimeter, and the segment NP is 4 centimeter. How long is segment MO now? So we have to use this formula. Okay, so 14 centimeter is equals to 1/2 of 4 centimeters times MO. Now, so again, we will simplify by multiplying both sides of the equation by 2. So 2 times 14 is 28 centimeters squared, and then 2 times 1/2 is 1. So 2 times 1, 2 divided by 2 is 1. Okay, then we will have this divide both sides of the equation by 4. Okay, 4. Okay, so 4 centimeter divided by 4 is 1. So we have here only MO. So 28 centimeter divided by 4 centimeter. So we have 7 centimeter. Okay, that is the measurement of segment MO. Okay, now let's have the midline theorem. Okay, what is a midline theorem? So the segment that joins the midpoints of two sides of a triangle is parallel to the third side and half as long. Okay, so we have this triangle BIS. Okay, now, and there is a midpoint. Okay, what are the midpoints? So point C and point A. And this one, okay, divide the triangle, and this mid segment or mid segment is 1/2 of the measurement of the third sides, and they are parallel. Okay, so let's have now problems involving midline theorem. Okay, so in a triangle MCG, A and I are the midpoints of segment MG and segment GC. Okay, now, so we have this given. Okay, if segment AI is equals to 10, so we will find segment MC. Okay, so this is 10 units. We are going to find segment MC. And another one, given segment GI. What is segment GC? Now, so we have these solutions. So, segment AI is equals to 1/2 of segment MC. So, remember the midline theorem that okay, the midpoint or the mid segment is 1/2 of the third side, okay, which is parallel to it. Now, so if segment AI is 10 units, okay, equals to 1/2 of MC, segment MC, so we are going to multiply both sides of the equation by 2. So 2 times 10 is 20. So this one will become 2 times 1, 2 divided by 2, 1. So remaining is MC now. So therefore, the measurement of segment MC is 20 units long. Okay, so if this is 20, this is 10. Okay, because of it is 1/2 of the third side is the mid segment. Okay, next, we have to find the segment GC. Okay, so we have here GC or CG is twice of GI, segment GI, because this is divided into two equal measures. Now, so if segment GI is 16 times 2, okay, so we can get the measurement of segment CJ or segment GC. So 2 times 16 is 32. So segment CG or GC is 32 units long. Okay, so I hope that you learned something from this tutorial. So please answer your learning activity sheets. Okay, God bless everyone. Bye-bye.